Okay, so why don't we get started here? It's 11 o'clock. All of you should receive assignment number 4 back since our last class. Were there any questions about it by chance? All of you are planning on going to ENAR now and spending $2,000? So today we will continue with the ethics section. I don't know if we'll get to the productivity tools. We'll see. Assignment number 5 is available. As I mentioned in my listserv post, please make sure you've downloaded it. We will discuss it some today. Let's see. So next time we will have a guest speaker, Pavel Chernyavsky. So are there any questions before we get going here? Okay. So we were talking about ethics. And so the next thing that we're going to talk about with ethics is with regards to what I've entitled Tell the Whole Story. And what I mean by that is, when you do a data analysis, you just don't talk about the, let's say if you do a data analysis and you do a report on it, you don't just talk about the stuff that supports your research hypothesis or your feelings towards the subject before going into the data analysis. You have to tell the whole story. Tell about the stuff that maybe does not support your research hypothesis. Another example of this outside of a data analysis, let's say if you're doing statistical research and you're doing a Monte Carlo simulation study that investigates maybe the true confidence level of a confidence interval. And then typically in these settings, and I anticipate that most of you have not done these before, typically in these particular situations you might be looking at the performance of a confidence interval. Well, let's just do the simple old confidence interval for a mean. And maybe you simulate your data under a normal distribution. Maybe you simulate your data so that it's chi-squared. Maybe you do logistic. Maybe you do Cauchy, and so on. Okay? So that's how you simulate your data. And maybe in these particular settings, when you calculate the estimated true confidence level, meaning maybe you simulate 1,000 data sets, and for each of the data sets you calculate the confidence interval for the population mean, and maybe of these 1,000, 94.9% of the time, the true mean does fall within the lower and upper limits of the confidence interval. Maybe for chi-square it's 0.940, maybe for logistic it's 0.956, maybe for Cauchy it's 0.875. Okay. Now in your research, and let's say if you're constructing a paper for this, when I say tell the whole story, don't just focus on that. You got to tell this part right there too. You got to explain that. Other classic cases of this include, let's say, if you're doing some kind of simulation study, and again you have 4 different situations, and in every single one you don't have problems estimating a statistic of interest, except for maybe your last one, where there maybe you did not get convergence of a particular statistical algorithm maybe about 10% of the time. You can't just throw those 10% out and just ignore them. You have to actually tell in a paper, yeah, 10% of the time it didn't work. I don't know, maybe that seems obvious, but I've had PhD students, when I'm first working with them, they just ignore that 10%. Well, there's something to be learned there that, hey, the method doesn't work 10% of the time under this particular setting. So let's talk about a specific data analysis situation. Now, it's going to take a while to go through this. My understanding of this situation involves reading a corresponding paper and also paying attention to the various media reports about it. And from just that, I call into question some of the choices that were made. But I don't know the whole story. Maybe there was an actual reason that I'm missing why researchers decided to do something rather than do something else. Okay. But this is my impression from paying attention to this story. and the corresponding paper on it. Okay, so September 24th, 2009, there were a number of news reports in terms of in newspapers, in terms of on TV, that hailed some research that was being done with respect to an HIV vaccine, and that finally it looks like that researchers have figured out a vaccine to prevent HIV in people. I mean, if that occurred, hey, that would be huge, a huge news story. And finally, and while they didn't necessarily find a preventative for everyone who took the vaccine in this particular clinical trial, it did seem to protect, according to the news reports and the paper, it did seem to protect some people. And that would be great if it was actually true. And so here's an example of some of this, and this is pretty much every newspaper, for various reasons, I've looked at a variety of newspapers on this particular day. Here's the Seattle Times, and a number of newspapers, even local ones here, ran with this story. Often it was the front page, if people still got a paper copy, it was front page news. And so, for example, they said, it cut the risk of becoming infected with HIV by more than 31%. If you end up taking my categorical class, this is often an example I talk about regarding a statistical measure called the relative risk. But anyway, there was also on TV news, if people still watch that, perhaps I'm showing my age, I watch the PBS NewsHour, and I recommend you take a look at the actual video on it, and it has some, I know it's kind of hard to see in this room, but it has some interesting graphics, and this news reporter here actually essentially shows the data that was used to make a judgment about this research study that supposedly this vaccine worked. Okay, so let's talk about this clinical trial that was done that led to this corresponding research paper and also the news media coverage of it. So it was a clinical trial performed in Thailand, and it's very simple. Study participants were given either the vaccine or placebo. Placebo meaning it's not the vaccine. It does not actually contain any active, let's say, ingredient that would help prevent HIV, or at least the researchers wouldn't think would help prevent HIV. So either a vaccine or a placebo. And the hopes is that the people who become infected with HIV who took the vaccine would be less than the ones who took the placebo. Now, so this clinical trial went over a number of months. There was a number of not dosages, but a number of reapplications of the vaccine to the same people who were in the vaccine group. Oftentimes, like I can think, for example, for chickenpox. That vaccine that's out there, you're actually expected to get two shots to make sure it was fully effective. And so with this HIV vaccine, people got more than one shot associated with it. And so on September 24th, 2009, some of the results were released, and this is what made headlines in the media. The full paper, though, was not actually published until October 20th, 2009. So like a month later, which is kind of interesting. And it was in the New England Journal of Medicine, which is thought of as one of the best journals out there. And what they released on September 24th was conclusions reached from looking at what was called the modified intent to treat data. Notice modified. In terms of who were they planning on actually being in the study, essentially. And they modified the data, again, look at the word modified, for some particular purposes that you'll see later. And basically they did a hypothesis test. were the null hypothesis that there was no difference in the probability of getting HIV for the vaccine or placebo group. And the alternative hypothesis was a difference. And we'll just make it even easier and say that the vaccine worked. Okay? I'm simplifying things, but I think you'll get the idea. And they got a p-value of 0.04 when they applied this a hypothesis test. You could do it with like a Pearson chi-square test for independence, if you're familiar with those, and get a p-value of 0.04. Basically, it was a 2x2 contingency table that they were working with. So, using the magical alpha equal 0.05 level, they said, "Hey, this works! Let's go tell the media now." That's what they said, or that's what I think they thought. So that's headline news. Okay. And then the paper was published October 20th, 2009. And they included 2 additional analyses looking at 2 additional versions of the data. The intent to treat, notice it doesn't have modified with it, and the per protocol. Okay. So let's look at what the intent to treat data said. Well, first of all, it was 16,402 participants, so a lot. The reason why there's so much is because since HIV has such a low prevalence, in order to have a good idea of what's going on, you need to have a large number of people in these kinds of studies, extremely large. So 16,402 participants. And these are individuals who were in the study, but perhaps did not complete the entire vaccine regimen. I think in the end they had to have essentially 5 treatments, if I remember right. And so maybe somebody decided to drop out of the study after only 3. Okay? If you look at that data, get a p-value of 0.08. Uh-oh. Now you're above that magical 0.05 level. What are you going to do? Now, the modified intent to treat data had 16,395. So essentially 7 people were removed from the intent to treat data. That's how you got the modified. Why were these people removed? Well, it actually does make some sense to remove them, and that is they were originally enrolled in the study, and then after they started receiving treatments, it was found out that they actually had HIV before they actually enrolled in the study. So maybe they walked into the clinic to enroll in the study, and the HIV test was done on them. The results were not necessarily back until after they started the treatment regimen. Okay, so it does make some sense to remove them, and that's where that p-value of 0.04 came from. Then there was also the per protocol data. This data consists of 12,542 people, so a subset of those 16 plus thousand. And these people actually went through the entire treatment regimen. So they didn't pull out early. And if you apply the exact same statistical methods, you get a p-value of 0.16. So again, now you're a little concerned. Okay. Now, interestingly, there's many, many interesting things about this whole study. Is that, these new results were publicized again, but no longer did it make headline news. Instead of, again, if you think of an old newspaper, instead of being on the front page, it was maybe on page 10. And so here, for example, is from the Los Angeles Times, what they said. A secondary analysis of data from the Thai AIDS vaccine trial, announced last month to much acclaim, suggests that the vaccine might provide some protection against the virus, but that the results are not statistically significant. Again, using that magical 0.05 level. In short, they could come about merely by chance, what was shown. That at least with those 16,000 or so people, that indeed there was a 31% risk reduction. Maybe, though, that was just by chance due to natural variation in the data. I mean, for those of you who are teaching like a class like Stat 218, That's what you teach when you talk about hypothesis testing. Okay, so given the results here, this leads to a number of questions. Why were the modified intent to treat data results released first? I will say here that I don't know the answer, but it calls into question why. I don't know, at least for me, I would think that they would have the intent to treat data. They would know the p-value was 0.08. Why would they not tell that part too? After all, a modified intent to treat data results in a modification of an intent to treat data, and you would think that you would have the intent to treat data to begin with. Why not say the p-value was 0.08 for this version of the data? Why not? Or even, I mean, I find it even surprising that they don't even talk about the per protocol in the original news release that they provided that led to the media coverage. And so, again, I don't know. I've never talked to the researchers. I don't know exactly everything that was behind this. This is just from me reading the paper and listening to the news reports. It really calls into question if these researchers, or maybe it was a university communications office, or maybe it was the New England Journal of Medicine itself, if they were really wanting to tell the whole story. Because if they told the whole story to begin with, I don't think they would have got the same kind of media coverage. So, this is a potential ethics issue. Next. This is as much of an ethics issue as just the ability to understand truly what a p-value is. And this is a big thing that has come up over the last couple of years. You know, I think I mentioned this in class, how some journals have banned the use of p-values. Are the results really different for the modified intent to treat and the intent to treat data? No, they're not. One has a p-value of 0.04, one has a p-value of 0.08. I don't really care if you use an alpha level of 0.05, alpha level 0.1, alpha level of 0.01. It doesn't really matter to me. All this is saying is that there is moderate evidence against the null hypothesis. We, unfortunately, people outside of statistics especially, but statisticians are not blameless here. We fixate on an alpha 0.05 so that, you know, if you get a p-value of 0.049999, hey, I reject. But if you get a p-value of 0.050001, oh shoot, I don't reject. I can't prove my research hypothesis is true. In the end, the conclusions should not change. I had hoped to talk about, spend a whole day talking about issues with p-values, but unfortunately we just don't have time this semester. And this is the one of the main things. Don't just fixate on a particular alpha level. The conclusion should not change. Perhaps that's counter what maybe you've learned in a class before, but what a p-value is just a measure of evidence against a null hypothesis. And I like to often think of, when I teach hypothesis testing to introductory students, I often give examples with regards to weather forecasts and what's the probability it's going to rain today based upon what a meteorologist has said maybe on TV or in the newspaper or whatever. And if a meteorologist said, hey, probability it's going to rain today is 0.04999, or they said this, would that change your decision about whether or not to bring an umbrella with you to school today? Probably not. Why should it change your interpretation of a hypothesis test result? It shouldn't. And I give some at the end of the notes, I give two references on p-values if you want to know more about that. Like I said, it's got a lot of interest lately. For example, the American Statistical Association statement on p-values, and also an author who's a professor at it's a university in D.C. Her name's Nuzzo. She has a very nice article that was in Nature about 2 years ago, and won an award from the American Statistical Association about p-values and properly interpreting them. And in the end, when p-values first were developed long ago, people weren't fixating on like alpha 0.05. They weren't doing that. It was just a measure of strength of evidence against the null hypothesis. Obviously, the lower that value is, the better. Okay. So in the end, to some respect, there's a problem with the media here not really understanding hypothesis testing. Whether p-value is 0.04 or 0.08, the decision shouldn't really change. But also in the original media, or the original news reports, original things given by the researchers, they shouldn't necessarily say, yes, we have found something. Well, either you have moderate evidence against it, or moderate evidence, but it's not full-blown. At least from my investigations that I've done after, since this was in 2009, I don't think this is necessarily anything has come of it, this result here. Maybe it was a type 1 error. So why didn't the media make as big of a deal about the result on October 20th as on September 24th? Well, again, it's more of interest by the media to cover stuff that you got a result versus I may have got something, I'm not necessarily for sure. That's just our society and what we live in. Also, just a little bit of a side note. You might be wondering, why am I not focusing on this right here, that p-value 0.16? Well, yeah, I mean, that is somewhat different than 0.04. I mean, it's 4 times larger. But also, I look at this right here. There's a lot less participants. I have no problems with interpreting this right here with these people. In this case, if with a p-value of 0.16, what would we teach students? Well, don't reject HO. Okay. Does that mean HO is true though? Yes or no? No, it doesn't. And I know when there's 4,000 less people there, what's going to happen to my power? What's power? Again, what's the probability you're able to reject HO, given that indeed you should reject HO, that HA was true? I know with a reduction of 4,000 people in these kinds of studies where the probabilities of actually coming down with the disease is so small, power is an issue. And so if you have 25% less people, your power is not as high as it once was. Okay, any questions? Okay, some additional comments. Make sure, of course, you acknowledge any assumptions inherent in a statistical method. Well, if you have to assume normality, you better say that you're assuming that. Discuss potentially important items that are not accounted for in analysis. This is a case of, this is a little bit more abstract. Let's say if you have two variables, x1 and x2, and you are unable to show that there is a relationship between the two, or maybe you were able to show there was a relationship between the two. But if you know that there's another variable, maybe you can or cannot measure it, called x3, that will matter here, well, you better mention that there's this other variable that you think is important. Account for a larger chance of an inference error as more or may. In stat 821, have you talked about Familywize confidence levels? Or maybe in other classes you've talked about Familywize confidence levels? Yes or no? No? Yeah, exactly. So let's say that let's say you have 10 confidence intervals and each are 95%. Okay? What's the overall confidence level that none of those intervals are going to make an error? Is it 95%? No. It's much less than that. Because each of these intervals are at 95%. I won't get into, I would assume that you will see this in 822. If you haven't already seen it in 821. So I won't get into it, but if you've ever heard like a Bonferroni correction, or use there's many other Chaffee family confidence or Shafay confidence interval. That's what that's talking about, to try to control the overall confidence level for all your inferences that you're making. You got to do that. Protect the privacy of the data, of course. Like some data that I work with, I'm not allowed to release to others. Recognize that results should not be made to conform to prior beliefs of a subject matter researcher. So in many situations when you're actually doing a statistical analysis, it's in conjunction with somebody who's outside of statistics, maybe let's say grain science or maybe psychology, and you're doing the statistical analysis for them. And they might have some preconceived ideas of what they think the results should be. You should not necessarily try to find manipulate the data analysis so that it does match what the preconceived conceptions are. And of course, use up-to-date methods. If you know something's better than something that was developed in the 1950s, well, use that something that's better. Okay, let's talk about the reproducibility of research. We do research because we want to, explore a particular hypothesis to see if it's true or not. And if your research hypothesis is true, that could be very meaningful. Let's say if you are involved with a clinical trial, you're testing a new drug to prevent a disease. Well, obviously, if this clinical trial is trying to be replicated in another setting, with other people, you would want the same kind of results to occur with that second clinical trial, because eventually this drug is going to be released to the general public. Without being able to reproduce research, the research has no meaning. So what causes then studies to not be reproducible? I mean, after all, again, often in the media, you see cases where, okay, first, chocolate is good for you. Then a new study comes out. No, chocolate's bad for you. Or I should use coffee. Coffee's an example where that occurs more often. And especially for those who are not scientists, that can be kind of confusing. Anyway, so what causes these studies not to be reproducible? Well, poor understanding of statistics by non-statisticians. Frankly, there you go. Imagine that some students that you're teaching in a Stat 218 class, suppose that's their only stat course. You think you're going to be able to apply statistics correctly when they're doing research? I'd be afraid. I'm afraid sometimes when I think of those individuals teaching my kids in school. Anyway, the integrity of the data and methods not being upheld, and this was previously the main section that we were talking about last time and just talked about now here. And the lack of explanation in terms of assumptions that were involved or how they actually came about with their analysis methods. Now, with respect to statistics research, we have made some improvements over the last 10 to 20 years about how we make our research reproducible. And the first one is simply through the use of R. As I've mentioned in my Stat 950, Stat 850 class that most of you are in, this has really revolutionized how we do research, because now people who are doing statistical research are using primarily R to do their stuff. And so now we're all communicating with the same language here. Also, R is free, and so that means anybody can use it. You can write a program that illustrates your statistical method or your new statistical method that you're developing, and somebody can immediately go execute that program themselves because they'll have access to the software. And R also provides a great avenues for dissemination of research. Now, a few journals, like Biometrical Journal, require a submission of programs, data, and additional results that were used in a paper. Now, most of you probably have not really delved into the statistical research papers and reading them a lot. And I look back, when I was a student 20 years ago, when I started reading papers, you think initially, because everything's gone through a refereeing process, that what's in that paper has to be correct. It's not necessarily true. Because in the publication process, until just recently, you were not ever expected to actually submit any kind of computer program that you use to do your stuff. And most things that we do nowadays in statistics requires a computer program. So the referee couldn't verify through the computer program that you were actually doing it right. You weren't required to submit the data. So in most statistics papers, at the end, the second to last section, there's going to be a data analysis section where you have some real life data that you're applying this great new statistical method that you developed. You're applying it to that to show, hey, I have solved this wonderful problem now with my new statistical method. But most journals now still do not require you ever to submit the data that was used in that data analysis. So how can anybody actually check that what you've done is correct? Now things have changed, or are changing. The first stat journal that I've seen really do this, and the one that I think still does the best job, is Biometrical Journal. We'll see a little bit more about what they do shortly. But one thing that all journals have done over the last 10 years is allow for a web appendix, where stuff that you were not able to fit into the paper because of publication restrictions. Every journal will say, at most you can submit a paper to us that is 25 pages, or something like that. And often editors will say, hey, I'll publish this, but you need to get it down to a shorter length. And what are you going to do? You're going to have to remove stuff. That stuff might have been important to help explain what's going on, or might give additional information about assumptions that you were making. Now with web appendices, though, that's no longer an issue. You can always put this additional information that will only be published online, not in the paper copy, that helps give further explanations. So this is directly from the Biometrical Journal website that discusses what they do, and I'll let you read most of this on your own. The one thing I want to point out is that this guidelines for code and data submission is a good read. Even if you don't publish papers ever, this gives some good criteria of what to do to make your programs to work with your data in a way that is reproducible for others. It's a good read. So just to give you an example of what goes into making a research reproducible, this was for Biometrical Journal, so this is with Bowen Zhang, who was a PhD student of mine. In addition to the paper itself, this is what we ended up doing. We had a 20-page web appendix that provided additional results. Sometimes I wonder with these web appendices if I'm actually writing a second paper. I wish I could get credit for writing a second paper with all this long appendix. I mean, I've had 30, 40-page web appendices. We had to provide in our program that can fit these proposed new models that we were developing, that actually implemented this new methodology that we were developing. We also included additional functions in an R package as well, so that people could actually use our stuff. And lastly, I wasn't able to share the data that I used in the paper with people. I wasn't able to share the data. It was a gonorrhea and chlamydia test results, and because of privacy issues, I wasn't able to share it so that people wouldn't actually be able to reproduce my exact analysis that I had in the paper, unfortunately. But what this journal required was you needed to submit some kind of data set that people could use just to at least try out your methods on, that would help them verify that, yeah, I am able to reproduce at least this additional analysis. And so this was just some simulated data that I put together to help do that. There was so Biometrical Journal was first. It was about 2012 or so that they first did that. And now some of the big journals, Biometrics, Journal of the American Statistical Association, JASA, they're following suit now, finally, with these reproducibility of research requirements with respect to the programs and code and stuff. There was a nice article in Nature about that. And again, Nature is meant to be across disciplines in terms of what their focus is. And they were focusing on JASA. And so this is the actual editor for JASA, who is basically in charge of the reproducibility of research. Her name is, I apologize, where is her name? Victoria Stodden. Just on a side note, when I see these pictures there, that's a nice picture there. So this is at the University of Illinois, I guess. She had this picture taken, and really nice picture. And sometimes I wonder, I always find it interesting, pictures taken like that help show off a researcher and stuff like that. Where you choose that, and just recently, I think I mentioned this in class. So in a much smaller setting, I had this picture taken in the library that we have on our department that talked about some of my research that was highlighted in Nebraska Today. But I always wonder, even with respect to music groups. Or other settings like that, how do they pick that why is the edge here, not looking at the camera? I mean, and I don't know, maybe it's just the artistic part of it, but anyway. Also, as those of you who are taking STAT 850 will find out, the ability to use the knitter package in R that allows you to combine your R code with the actual text of a paper or report or answers to a homework assignment really helps with respect to the reproducibility of research too. Just real briefly here, make sure unfortunately errors in programming happen. Make sure you check your results and try to minimize your errors. In any kind of research that you do, make sure you include major competing methods in comparison for statistical research. Unfortunately, this happens where somebody proposes a new statistical method and they try their method out on some known to be inferior procedures, and they say, hey, look, my method does better than these. But then they forget, well, there's this other procedure too out there. Why didn't you compare it to that one that is known to perform well? I've seen people do this with my research, where they ignore some of the methods that I know that are best, and they'll just to show that their method's better, and they ignore maybe some of my stuff, but they'll try some of this other stuff that is known to be worse. And whenever possible, share data. So if another researcher asks you, hey, can I have the data that's in your paper, that you use for your paper? It would be nice if you can give it to them. Again, I run situations where I'm not able to, but what I do is I hook these people up with my data source. That, hey, if you want to do this, go to there, and you might be able to get the data from them, and that has occurred often. Okay, so I have a number of additional resources that I think will be useful. Obviously, you're not going to have time this semester to read all these, but at least I want to put this out there, especially if you come into a situation where you feel as though that I might have an ethics issue here. I'm not for sure exactly how to handle it. So here are some resources at UNL. The ASA's Committee on Professional Ethics actually has a number of good case studies that you can look at. Also, let's see now, what's another good one? Here's an interesting paper entitled Most Published Research Findings Are False. The International Statistical Institute's international work helping on ethics cases. Let's see now. What I found interesting, I did not know about this until putting together this this lecture, is that actually North Carolina State actually has a full course on ethics that it requires their PhD students to take. I've never seen that in any other department of statistics before. There's more information about it there. And here are these references on p-values. Are there any questions? Okay, let's take a look at the assignment. Okay, there's two main problems. The first one is I would like you to read through the entire ethics guidelines as given by the ASA and the ISI. Now, to show me that you indeed have read through them, list 4 guidelines in total that statisticians should follow and were not discussed in our class. I wasn't able to talk about everything that's in these guidelines. I, again, picked ones that I thought that were of interest definitely for students now, and that were also would be of interest later on. Make sure you cite the locations in these documents where you found these guidelines. So like, give me a page number, give me a line number, so that I'm not struggling trying to figure out, okay, where did that come in? Now, obviously in this kind of a situation, you know, how much you get out of it is somewhat dependent upon you. And this is in total of, in terms of your entire research, your entire schooling. You know, are you going to read this and read the first page of, let's say, the ASA guidelines and find 4 and just write those down? I hope not. Again, it will benefit you if you read the entire thing and find 4 from that. Number 2, anybody watch the show Last Week Tonight with John Oliver? Okay. Well, he has an interesting show. In fact, he was trending this morning on Twitter for some stuff he was saying about Donald Trump. I haven't watched that yet, so I'm anxious to watch that probably this evening. Anyway, so John Oliver, his show attempts to discuss in a humorous way topics about science, topics about politics. And I want you to watch a particular episode that aired on May 8th, 2016. Now, whoops, did I just show you the one with the answers? I hope not. No, okay, I did, good. I went through a number of iterations of this, and I was worried I was seeing something I shouldn't see. Maybe. Okay, good. Anyway, so his show can use some language that I will not actually use in our class here. Also, his show talks about certain things that I would not talk about in a classroom here. If, by chance, that makes you uncomfortable when you're watching the show, you don't have to do this particular problem here. You don't have to watch it anymore. And I can give you another problem to work on that doesn't contain the same language, same topics. Anyway, but I hope you at least try to give this a try. So what I want you to do is watch the video and answer these 5 questions regarding what was covered in the video. And he talks a lot about stuff, just about something called p-hacking, which is the incorrect use of p-values, without getting into more detail than that. And it just has some interesting things about ethics problems with the media, but also ethics problems with science itself. So, anyway, so that's the assignment. Are there any questions? This is due, let's see now. So it's due on Wednesday, November 23rd at noon. Note that school's not in session then, but since you turn in everything electronically, you can still turn it in then. If you don't like that, well, you can always turn it in on Tuesday when school is in session. I'll still accept it. Okay? Are there any questions about this assignment? Okay, well, in the remaining time then, so we've got 6 minutes left. I want to make sure you get your money's worth here. Let's move on to this next set of notes. We obviously will not complete it. I don't know if we will ever complete it, but we have time, so let's get started. So productivity tools. At least for me, I try to be as productive as possible, meaning I think of productivity as being also closely associated with efficient. You know, if a new tool is going to let me be efficient, meaning I can get something done in a half hour versus an hour, I'm going to try to use that tool. And while at first it might take me some time to learn that tool, in the end I know it's going to benefit me. And so, obviously, with being involved in graduate school academics life now for over 20 years, I feel as though I have some good ideas of how to be more productive, how to be more efficient. Some of these ideas might work for you, some of these ideas may not. But a lot of these ideas come about of, if I was a student, this is how I would go about doing things, because I think it would work. Now, some of these tools that I have listed here, I expect that some of you are already using them. But I wouldn't be surprised if some of you are not. So first of all, always make sure you back up files on your computer. This might seem like a simple thing, but I've run into a number of times with students who tell me, my computer crashed, and I don't have a backup. That's sad, but it happens. And perhaps I go overboard. I mean, I remember when I was doing my dissertation, this was in the late 1990s and in 2000, I would have a zip drive. Does anyone know what a zip drive is? Anybody ever heard of a zip drive before? Okay. Well, back before there were zip drives, there were just little diskettes that would hold 1.44 gigabytes, 1.44 megabytes. And then these zip drives came out, and basically it was like a zip disk was like the size of a regular diskette, and it would hold 100 megabytes. Wow. So, like how we use simple USB drives now that can hold probably 64 gigabytes. I had a 100 megabyte zip disk that had a zip drive that plugged into my parallel port on my computer, if you've ever heard of those, and I would back up once a week all of my dissertation work. And I was so obsessed with worrying about losing my dissertation work, what happens if my computer crashed, that and my wife just loves this story, that like I was dating my wife at the time, we weren't married yet. I would take my zip drive, or not my zip drive, my zip disk with me on dates, because I was afraid, what happens if my apartment burned down and I lost my computer? Well, I would take that zip disk with me, because that's my backup. I can't lose it. So, anyway, fortunately we don't have to do that anymore. One reason is because we have cloud-based storage. How many of you use cloud-based storage? Good. I first asked students this in 2013 in a class I was teaching, and I was surprised that none of them really knew about it. And I'm glad that students are learning more and more about that. And I think partially it's because I think it was in 2015 or was it 2014, one of those two. It's been 1 or 2 years that the university has had an account with one cloud storage company called Box. And then all students here have access to an unlimited amount of storage that you can use with Box. There are better, I think, cloud storage-based alternatives out there, but Box is okay. And the fact that it's unlimited is great. I give some directions here in case you haven't used it. You can learn about that. My favorite, and what I think is the best one of all of them I've ever seen, is Dropbox. One reason is because it actually saves previous versions of files. So a number of times that I've used this now for 6 years or so, a number of times where I'll make a change to a document, I'll save it, close out the document, and then a day later I think, oh, I shouldn't have done that. I shouldn't have made that change. I need to see what I had there before. Fortunately, with Dropbox, there's previous versions of my files that will be saved, and I can go back to that previous version and download it from the cloud and restore what I need. Not all cloud-based storage methods have that available. Another thing that's useful is that you can synchronize files and folders across computers. So sometimes we use more than one computer. Hey, you can have the exact same thing on one computer as another. And one place where that is handy is especially if you're collaborating with others. So for example, with my analysis of categorical data with our book, This was actually the reason why I first started using cloud storage in 2010. My co-author, who's based in Vancouver, BC, and I shared about 1 gigabyte of files via Dropbox so that we could both edit and make changes to our book at the same time. It was a very, very useful tool. I don't know what I would have done without it. Okay, it's 11:50, so we are out of time here. Are there any questions? Okay, that's it for today.